In this tutorial, I'm going to show you how to use the website Eyes on Exoplanets, which is a fantastic tool to learn more about exoplanets or planets outside our solar system. So when you load the page, you can just close the message here. And this is the view you start with. It's a bit strange. We're far away from Earth. We're actually over 3,000 light years from Earth with the sun in the center. And these are all systems for which we have found planets around the star. So we're actually looking at over 5,800 confirmed planets in a total of 4,373 systems. So we're looking at, again, like over 4,000 solar systems in this field of view. These numbers will probably change from the time I record this video to the time you actually visit the website, because we keep finding new planets. Something you might notice that's a bit strange is this here. It looks like we have more planets in this direction. It's simply because one of the main telescopes that has been used to discover exoplanets, the Kepler telescope, was actually looking in this direction. So this is sort of the field of view of Kepler. It found a lot of exoplanets. It doesn't mean that there's more here. It just means that that's where we've looked. So that's why it looks like this. In this view, you can zoom in and zoom out like this. So that's one way, and you can click on any systems you want. One thing I like is to come here in the parameters, in the settings, and use the numbers instead. So what we're looking at right now are the number of known planets in the system. So you can see for most of them, it's 1 or 2. Let's have a look. Oh, there's a system with 4 right here. So let's go visit the system K2-187. When you come here and look at the system view, you see the star in the center and the orbits of the 4 known planets around it. Now we're in a system over 1,000 light years away from Earth. And what we see here is what is called the habitable zone. This is the region in which the temperatures of the planet could be suitable for life as we know it. So between 0 and 100 degrees Celsius, where we can get liquid water. It should be called the temperate zone. Unfortunately, the name habitable has been used for a long time. You can remove it if you want. And anyway, what's more interesting is to look at the planets. But what this also indicates is that the planets in this case would be much too warm, much too close to the star to have life as we know it. One thing we can do is to compare this system with our own solar system. So you can see that all the planets here are much closer to their star than even Mercury is from the sun. So it kind of gives you an idea of how small this system is and how close the planets are to their star. What we're going to do now is click on a planet. If you click on it, then you get the planet view right here. You can also switch from one planet to the other here. Now, you might have seen it says hypothetical visualization. This is a drawing. We don't really know what the planet looks like. We can't see planets with this level of details at all, but it's just a lot more fun in this program to put a rendering of a planet than just a gray sphere, for example. But this is not what the planet really looks like. That's important to understand. Now, if we want to know more about this planet, the important thing to remember is to come here and click on the plus sign. We can see here it's a potentially rocky world larger than Earth. Now let's have a look a bit more. This is the page with a lot of information. Again, artist concept. The same image is used over and over actually in the system. So you might see this image from many more planets. It tells you a bit about it here. You can compare it here with Earth. So the planet is a bit larger than Earth. It's more massive, about 2.5 times the mass of Earth as well. And we can compare the star with our sun. Our sun is actually slightly bigger than this star. You can see as well the orbital radius, which is how far the planet is from its star. By definition, the Earth would be 1. This is astronomical unit. And by definition, the Earth is 1 astronomical unit from the sun, which means this planet is about 4% the distance from the sun to the Earth. So it's actually extremely close to its star. And it orbits in just 2.9 days. So its year, the time it takes to go around its star, is 2.9 days compared to 365 days on Earth. Something interesting here is to give you an idea of the distance, how far it is from us. So from Earth, how long would it take to travel there? If you were going by car at 60 miles per hour or 100 kilometers per hour, it would take you 10 billion years. So it's extremely far. If you're going at light speed, it would take you 1,000 years, and you can try anything in between. Like the Voyager probe, for example, would take 19 million years to get there. Then if you scroll down, you can find more information about how it was discovered. This is using the transit method, and it was observed by K2, which is the continuing mission of Kepler. So this is where you can get a lot of information about the planet. Something interesting when you come back to this view here is that you can say compare to Earth. And then you can see them side by side. So that gives you an idea of how big it is. You could also compare to Jupiter. So it's much closer to Earth. Now let's have a look at the system. We could also compare the star. We could have a look at the star and compare it to the sun. So in this case, there are very similar stars. You might find systems that are quite different. So once you've explored a system, you can come back home to the starting view. You can browse around. You can search for a specific system. If you want, for example, I could look at the TRAPPIST-1 system, which has 7 known planets around this star. You can also look for more information on the missions. I told you about the Kepler telescope. There's also TESS, or the observatory, the observatories that have been used to discover exoplanets. And for example, you could have a look at the Gemini Observatory, which is in part Canadian, and find some of the planets it has discovered. So it's a really nice program. Have fun exploring it. In general, the students enjoy using it as well. And this way you can learn more about exoplanets.